8.5, slope-intercept form. In this lesson, we are going to look at exactly that, the slope-intercept form of a linear equation. We've already talked about this a little bit. In fact, in a couple of sections before, the book called it function form. We're calling it slope-intercept form now. What slope-intercept form is an equation that is basically solved for y. So when you have it solved for y, what we learned yesterday was that the slope is the number or the coefficient of x. Okay, but what we didn't really learn is that the other number, this number that's represented by the letter b, is the y-intercept. And if you remember, y-intercept is where the line crosses the y-axis. So in this example, here the slope is 2, and the place where this line crosses the y-axis, the y-intercept, is 3. The y-intercept is called b, and the slope is m. Okay, so identify the slope and y-intercept of the line. Well, slope is the coefficient of x, and in this case that is 1. Okay, the y-intercept is b, which is -4. Here, you have to solve for y, so I'm going to subtract 3x. Again, move x, divide by the number in front of y. Okay, every time. So -3x plus 10, divide by 5, divide by 5, divide by 5. I get y is equal to -3/5 x plus 2. Okay, here's the slope. M is equal to -3/5, and b, which is the y-intercept, is equal to 2. Okay, next page. Now we're going to graph using those 2 points. Now this will be a little new, but it's fairly easy to do. Okay, first we're going to solve this for y. Now we got one step to do here, and that's get rid of the 3. So I want to do that, and I get y is equal to 2/3 x plus 4. Now remember, in slope-intercept form, the number in front of x is the slope. And remember, slope is rise, the vertical change over the horizontal change. And the y-intercept is 4. So what we're going to do to graph these is put a point on the y-intercept, 1, 2, 3, 4, right here. Your first point always goes on the y-intercept. Then we're going to use the slope to get our second point. Remember, it's 2/3. The top number is how high we go. The bottom number is how far over. And so it's rise over run. So it's 2/3. We go up 1, 2, and then over 1, 2, 3. My next point is here. And then I can successfully, well, not with this tablet, but you could draw a line between those 2 points. And there you have the graph. Okay, let's look at the next one. -x plus 1. This one's already solved for y. What is the y-intercept? Well, it is 1. My first point always goes in the y-intercept. Now I'm going to use the slope to graph. Well, what is the coefficient of this? It's -1. Well, remember, when we're using slope, we kind of need a fraction. So we got to think of that as -1/1. Okay, the top number is how far up and down we go. The bottom number is how far over. So -1/1, that the top number is how far down. Because it's negative, we go down 1 and to the right 1. There's my second point, and if I needed to, I could keep going down 1 and to the right 1, down 1 and to the right 1. I could get several points, and then, still not quite drawing a line through those points with this tablet. Anyway, you get the picture with that. Let's look at the next equation that we have. What happened? We can't do that for some reason. Let me erase this. Okay, next equation is 3x minus 2y equals 6. We're going to subtract 3x from both sides. We're solving for y. That is a must. -2y is equal to -3x plus 6. Divide by -2. And we get y is equal to +3/2 minus 3. Okay, the first point on your graph goes on -3. 1, 2, 3. Okay, then we're going to use the slope 3/2. So I'm going to go up 3, 1, 2, 3, over 2, 1, 2. My second point goes there. And then let's see if I can do this a little better. I did make it through at least one of the points with my line. And there we've graphed that one. Notice the slope is positive, and I have a positive graph here that just kind of helps me to check myself and make sure I'm doing it right. Next one, 4x. This is already solved for y. Now we don't have a b, y-intercept over here. We have to think of that as 0. Okay, if I don't have a y-intercept, it's 0. The slope is 4. We can think of 4 as 4/1. Okay, so we're going to go up this many and over that many. So I'm going to go up 4, 1, 2, 3, 4. and 1 here, then I'm going to try to successfully hit both those points, getting a little better. Okay, that's graphing using the slope-intercept form. Let's look at a word problem. Temperature at Earth's surface averages about 20 degrees Celsius, and the crust below the surface, the temperature rises by about 25 degrees per kilometer of depth. This is a rate. Rates, we say, go with x. Okay, write an equation that approximates the temperature below Earth's surface as a function of depth. Now, when you see this as a function of, that's telling you what x is. Okay, so y is the temperature below Earth's surface, whereas x would be dealing with depth. So function of depth, they're saying it's a function, and we're talking about x is being depth, whereas y is the Earth's temperature below the surface. So we're going to say y is equal to, now this is our rate that goes with x, right? 25x. Okay, and our starting point is here, plus 20. That's where we start at. Okay, so as we go down below the Earth's surface, we are rising 25 degrees, but we start out at 20 degrees, so we have to add that to the mix. Now notice our rate is actually a slope, and our starting point is actually a y-intercept. Okay, just wanted you to notice that. The rate, when we were writing equations earlier, our rate is actually a slope, and the other number is actually the y-intercept. So if we're going to find the maximum depth at which these bacteria can live, 110 degrees is going to be our total, and we're going to solve for x. I think it's 110. We're going to get something a little bit weird. So we're going to subtract 20 from both sides. Okay, so I get 90 is equal to 25x. I'm going to divide both sides by 25, divide both sides by 25. So I get this fraction, which is going to be 3, let's see, in 15 over 25, which if we divide, it's going to be 3 3/5, or 3.6. And that is in, let's see, kilometers. So we can see that this will serve, the maximum depth that will survive is 3.6 kilometers. We're using this unit that they gave us in the original problem. Okay, let's look at another problem. Well, look at something else. Slope of parallel and perpendicular lines. If two lines are parallel, that's telling us they have the exact same slope. In this case, the slope of this line is 2. These two lines are parallel. Now these two lines here are perpendicular, okay? And what we have to see about that, now when you see this little red, box in between the two lines, that's the symbol for perpendicular lines, okay? Now if this line has a slope of 2, this line is the negative reciprocal of that. So basically we've got 2 over 1. We flip it over, we got 1 over 2, and it's a negative 1/2. So with parallel lines, they're the same. With perpendicular lines, they are the negative or the opposite reciprocals. Okay, let's look at the next step. For the line with a given equation, find the slope of a parallel line and the slope of a perpendicular line. Well, this one's pretty easy. The slope of a parallel line would be -3. We'll just call that parallel lines. Okay, so that would be -3. The slope of, well, you can't really do that, can you? Parallel, here's what we'll do. We'll call parallel lines, that would be -3. Perpendicular lines would be the opposite reciprocal. So it would be 1/3. It's already negative, so the opposite would be positive. Now here for parallel lines, and that's the symbol for parallel lines, if you're wondering, the slope here is 4, so a parallel line would have the same slope. Okay, now perpendicular line, and this is the symbol for perpendicular lines, okay, is the opposite reciprocal. So we flip that over, it's 1/4, and we just change the sign of it, we get -1/4. Okay, here, let's do one of these. I don't know if we have time for too many of these. We're going to subtract 2x from both sides. We get -5y equals -2x plus 15. Divide by -5. We get y is equal to +2/5 x minus 3. Okay, the slope of a parallel line is the same as that, which would be 2/5. Perpendicular line would be the opposite reciprocal. So we flip it over and we change the sign. Okay, and that's finding slopes of perpendicular and parallel lines. I'm trying to keep this video a little short. Let's graph a few more things here. Let's graph 2x. Okay, now the y-intercept is 0 because there's nothing here. So we're going to say b is 0. We got to think like this. Point goes here. My slope is 2. We got to think of that as 2 over 1. So I'm going to go up 2 over 1 and draw a line through that. Okay, let's look at this one. We have a y-intercept of 4, 1, 2, 3, 4, and a slope of -3. So we're going to go, it's -3 over 1. So -3, we go down 3, 1, 2, 3, over 1. We have a point right there. And we're going to try to draw a nice, well, I wouldn't call that nice, but a line through those 2 points. Let's look at this one, y equals x. Well, think of that as plus 0. So we have a point here. And we're going to get kind of messy. So we need to kind of erase this over here. Okay. So we've got a point at 0, and the coefficient of x is 1, and it's 1 over 1. We got to think like that. So it's up 1 over 1, up 1 over 1, up 1 over 1. So there's enough points there to graph a decent line through those things. Look at this one. Well, here the y-intercept is 9. So I go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. -6 is the slope. It's -6 over 1. So I go 1, 2, 3, 4, 5, 6 over 1. And if I wanted to, I could go down 6 again. 1, 2, 3, 4, 5, 6 over 1. So there we've got 3 points instead of 2. Sometimes it's a little better to make an accurate graph of the line. That's not accurate. Okay, so there. We've graphed a few more lines using slope-intercept. Remember, what I want you to remember here, solve for y. Your first point on the graph goes on the y-intercept. That's on the y-axis, not the x-axis. So you plot your first point. Then you use the slope to get your second point. So you're going to start at that first point, and you're going to use the slope to go up and over, or down and over, to get your next point. Once you have 2 points plotted, you can draw a line through those. And that pretty much takes care of this lesson.